Look at this image. This was taken just days ago, not by an artist, not generated by AI, by a real spacecraft orbiting Mars right now. And what you're looking at is a scar, a wound carved into the surface of an entire planet, one that stretches nearly 1,300 kilometers across the Martian equator. That's the length of Italy, gouged into the ground in a single catastrophic event. 3.5 billion years ago, something went very, very wrong on Mars. And these new images, released just this week by the European Space Agency, are our clearest look yet at what that something was. To understand what happened, we need to go back, way back. About 4 billion years ago, Mars wasn't the frozen, rust-coloured desert we know today. It had a thick atmosphere, temperatures warm enough for liquid water, and most importantly, it had oceans, real oceans, covering a significant portion of the northern hemisphere. Scientists have been piecing this together for decades. The evidence is everywhere if you know where to look. Ancient river deltas, dried lake beds, mineral deposits that only form in the presence of liquid water. Mars wasn't always dead. In fact, for hundreds of millions of years, it may have been one of the most habitable places in the entire solar system. And then something changed. The planet started dying, slowly at first, then all at once. The atmosphere began to thin, temperatures plummeted, the oceans began to disappear, and the water, all of it, had nowhere left to go. So it went underground, vast quantities of liquid water retreating beneath the Martian surface, freezing, hiding, locked away in enormous underground reservoirs deep beneath the rock. And there it stayed, for millions of years, waiting. But underground water doesn't just sit still forever. Over time, pressure builds. Heat from beneath the crust keeps parts of it liquid, and eventually, inevitably, something gives way. Scientists believe that's exactly what happened at a region called Xanthe Terra, a highland plateau near Mars's equator. Something triggered a catastrophic release, maybe a massive impact, a meteorite punching through the crust above a pressurized reservoir, maybe volcanic activity heating the ground from below until the ice above it melted all at once. We're not entirely sure what the trigger was, but we know what happened next. The ground collapsed. An enormous section of the Martian surface fractured, buckled, and caved inward as the water and ice beneath it gave way. And then the water came, not as a trickle, not as a river, as a wall. Billions, possibly trillions, of tons of groundwater erupting onto the Martian surface simultaneously. The scale of this flood is almost impossible to comprehend. Scientists estimate it would have dwarfed anything in Earth's geological history. The largest floods our own planet has ever seen, the great Ice Age megafloods that carved the English Channel, that drained entire glacial lakes in weeks, would have looked like puddles compared to what happened here. This was the most catastrophic flood in the history of the solar system, and it carved Shalbatana Vallis. Shalbatana Vallis, even the name sounds ancient. It's an outflow channel, a term geologists use for valleys created not by slow, patient rivers, but by sudden, violent floods. And it begins exactly where you'd expect, right at the collapse zone, right where the ground caved in. From above, that starting point looks like something from a science fiction film. The terrain there is what planetary scientists call, and I love this term, chaotic terrain. And honestly, that name does not oversell it. Imagine standing on a flat plain, and then, over an enormous area, the ground has simply broken apart. Huge blocks of rock tilted at strange angles, deep trenches cutting between them, mesas rising randomly from the fractured surface. It looks like a giant reached down and just crumpled the planet. What actually happened is that as the water escaped from below, the ground above it lost its support, and it collapsed, unevenly, chaotically, leaving behind this labyrinthine, fractured landscape that still looks violent 3.5 billion years later. From there, the floodwaters didn't hesitate. They surged downhill, carving through rock that had stood for billions of years, cutting the channel deeper and wider with every passing hour. Shalbatana Vallis winds its way for 1,300 kilometers across the Martian surface, weaving, turning, broadening, before it finally empties out into a vast, flat lowland plain to the north, a plain called Chryse Planitia. And this is where the story gets really interesting. Chryse Planitia. It translates roughly as the Golden Plain, and from orbit it looks exactly like that, a smooth, relatively flat expanse in Mars's northern hemisphere. But look closer, study the geology, trace the ancient shorelines, and what you find is evidence, strong, compelling evidence, that Chryse Planitia was once the floor of an ocean. Not just any ocean, an ocean so large it covered most of Mars's northern hemisphere, an ocean that Shalbatana Vallis, along with dozens of other outflow channels nearby, helped to fill. Think about what that means. Every catastrophic flood that carved these enormous channels across the Martian equator was ultimately draining northward, pouring water into this growing northern sea. Mars didn't just have water, it had a hydrological cycle. Rain, rivers, oceans, evaporation, clouds, a living, breathing water world. And then it was gone. All of it. The ocean, the rivers, the clouds, the rain. Gone. So what happened? What could take a planet with oceans and turn it into the barren, frozen desert we see today? This is the question that planetary scientists have been chasing for decades, and the answer, when you find it, is both fascinating and deeply unsettling. Mars once had a magnetic field, just like Earth does, a protective bubble generated by a churning liquid iron core that surrounds the planet and deflects the solar wind. The solar wind is a constant stream of charged particles flowing outward from the Sun at hundreds of kilometers per second. On Earth, our magnetic field deflects most of it harmlessly around us. But on Mars, something went wrong with the core. Around 4 billion years ago, Mars's interior began to cool too quickly. The liquid iron core, the engine of the magnetic field, started to solidify. And as it did, the magnetic field weakened. Then it collapsed entirely. And without that protective shield, Mars was defenseless. The solar wind hit the Martian atmosphere directly, and it began to strip it away. Not all at once, but relentlessly, particle by particle, year by year, over hundreds of millions of years. The atmosphere thinned, atmospheric pressure dropped, and when atmospheric pressure drops low enough, liquid water becomes impossible. It doesn't freeze, it doesn't flow, it simply evaporates straight into space. The oceans didn't drain away, They didn't freeze solid, they evaporated, molecule by molecule, lost to the void. And the Mars we see today, cold, dry, battered by radiation, is what's left. A ghost of what it once was. But here's what keeps scientists up at night. Mars had liquid water, potentially for hundreds of millions of years. It had energy sources, chemical gradients, all the raw ingredients that life needs to get started. On Earth, that's all life needed. Within a few 100 million years of liquid water appearing on our planet, life emerged. Simple microbial life, but life. So the question isn't just, did Mars have water? The question is, did anything live in it? We don't know yet, but Shalbatana Vallis and the ancient ocean it helped to fill is exactly the kind of place scientists want to look. Because if microbial life ever existed in that ancient Martian ocean, some trace of it might still be preserved. In the sediment, in the rock, waiting, just like the water once was, to be found. Mars hasn't given up all its secrets yet, and with every new image from orbiters like Mars Express, with every rover that crawls across that surface, we get a little closer to the answer. Mars is trying to tell us something. We're just learning how to listen.